I'm an Odoo employee for more than 11 years now. Probably some of you have already seen my face walking around. This is one of the questions that comes to me quite often from developers outside Odoo, but even from inside Odoo, which is, why don't we use this RM or this one, which looks much more cool, more Python 3 enabled or whatever, this one which looks much more efficient, and plenty of things like that. And there's a few reasons, and I'll explain some of those reasons, and there's at least one reason that potentially somehow disqualifies almost any other application framework. And we already mentioned it, but I'll come to explain why we somehow need to make ourselves our own framework. It's not just for fun and things like that. So the first thing I'm going to explain is basically to define exactly what I mean by the server-side framework. We already mentioned there's a server-side framework, there's a client with its own framework, and there's even the website which uses their own stuff and reuse partly the website framework. I'm just talking about the server-side framework, which is the Python thing. We're often referred as the Python framework team. Then I'll explain you some of the reasons, and I'll somehow make them more explicit by showing the features that make our framework a little bit different from the others, and that benefit from one of those key reasons. Actually, there's one main reason for not reusing any framework outside of Odoo. If I have some time, I'll compare a bit to other frameworks that share some of the specificities, the features, and none of them actually somehow has all the characteristics we need for Odoo. So let's talk about the stuff, the real stuff. What is Odoo? Odoo is, I won't call it an application. It's actually many applications in a suite. And they're integrated. And for the purpose of this talk, I'm going to use interchangeably application as Odoo modules. So basically, every Odoo app is a module. Some modules are not really apps, but they somehow do integration between apps and things like that. So you've got a database, an Odoo database, and on that database, you're said to have installed a certain number of Odoo modules. And so you can have, in fact, an Odoo instance with only a small subset of the applications. You're not forced to have everything. It's not an all or everything. You can have just a subset of the applications, and that's actually the good way to use it. And the fact that we have modules also somehow opens the framework to, and the application, the Odoo application as a whole, to third-party applications, and many of you actually take advantage of that. And it's not just a framework, but it's also a server, a web application server, and this word is what makes it more, let's say, technically challenging. It's a multi-tenant, which means that one server can serve many databases, but not all the databases that are being served have to have the same modules being installed. And this is actually what makes this combination, being multi-tenant and somehow multi-modules, this is a challenge, technically speaking. And most other frameworks don't enable to do that easily. Not as easily as we do. So the server framework itself, so it's basically the core of the server. It's mostly three things. It's an ORM library. There are other ORM libraries, of course. It's an application framework, and it's also an HTTP framework, because we have a website, so we can define controllers and things like that. The application framework part, essentially, that's for dealing for all the interactions with between the server and the client. And the ORM library, it is similar to other ORM libraries. Essentially, that's an API to get access to a relational database, but without having to deal with all the SQL and the stuff, very low-level details of the database. And one thing that's a bit characteristic of Odoo is that it abstracts basically more than most ORMs. Most ORMs, basically, you're pretty close to SQL queries anyway. Odoo somehow abstracted a bit more, possibly at the cost of a little loss in performance. But that's a trade-off, of course. And now, why is it so unique? I'm going to come to those reasons. First, reasons are simply historical. Because Odoo has about 20 years now. We actually had a kind of a birthday event inside Odoo. And the framework is actually 20 years old. And if you look at what were the available ORMs, specifically for Python, because Fabien chose Python as his favorite language, there was actually very few options, if mostly none. And actually, none of the existing libraries really was fitting what was necessary. And the last reason, it's of course because Fabien's a really, is he a real developer? And so developing a framework is always a lot of fun, a lot of challenges, and it's fun, yeah. Every developer should write a framework someday. We have, I would say, more human reasons because, okay, we have a whole team on the payroll for managing that framework, but that's just for kidding. One thing that somehow enables us, which makes us slightly different from other frameworks, most other frameworks, basically, they come as a library, and backward compatibility is not a joke. Basically, they want to keep it extremely stable, extremely without bugs, and very reliable. We're less stable, clearly, but the trade-off is that we try to improve, and basically every release of Odoo is an opportunity for us for somehow possibly breaking some feature and re-implementing it completely different, or present it in a different way at an API level or whatever, which is less the case in other frameworks. And of course, because it's still fun to work on such a thing. And then this is what I already mentioned. Because our server is multi-tenant, so multi-database and multi-module, the server processes several databases, several instances. Each one has its own modules. And therefore, each database must have its own data models, fields, views, and so on. And because of those constraints, you have to deal with the fact that it's not just enough to declare some classes, having a meta class that just glue them together and just run the code, because the code being run must be different on every database, even on a single server. And that's what makes our server pretty unique. In order to somehow illustrate some of the things we're able to do, and this comes with the modularity that we provide. The modularity at the level of the Odoo modules, not the modularity of the implementation of the framework, but the framework allows to make applications more modular in a sense that you can actually extend existing models. Habib already mentioned that. So you can take an existing data model and add more fields, add more methods, possibly override the methods that implement a business process and things like that. It's usually not that easy with other frameworks. Basically, you have a more holistic approach if you take some other frameworks. I'm going to mention that. And computed fields, I mentioned computed fields not just because the others don't have it, but because the computed fields, it's a way to inject some dependencies from a model to another. Let me explain that on an example. This is the only code I'm going to show. So this is what I told you. Essentially, imagine you have a model called foo in whatever module, and you decide to, in your own module, extend that model, add 2 more fields, and the second one, for instance, it's a computed field, and here's the code that computes the value of the field, and this part, the dependency, this is actually a dependency injection. Why? Because essentially, this is the only code I have to write, and what the framework gives me, somehow, not magically, it's actually completely programmed, but it's a dependency between the model REST partner and the model foo. And this dependency injection is if you modify the partner which is related to one of those records, and you modify this field website, the framework will automatically determine which records in the model foo are impacted and must be have the field important recomputed. The framework actually provides that somehow for free. Typically, if you had written this in something like Django, you cannot do that in Django. Basically, you would have to essentially twinkle around and go to the implementation of the model of the partner, and there override the method that would allow you to write on the partner and essentially catch when you actually try to modify the field website to say, oh, I have to search for the records in the model foo that actually related to the one I'm modifying to make sure they are updated and the field is recomputed as well. In Django, you would have to write that. And I mentioned this example because I have a former colleague who one day decided to write a small application which was a pet project on its own, and he decided, okay, Odoo is a bit heavy for the task and stuff like that, so he decided, I'm going to go with Django. It's going to be faster. And he told me afterwards that he was missing the computed fields. He felt this was missing. It's so easy to write this way, and especially in something like an ERP, this really helps you go a long way. Those are extra technical stuff Odoo has. I'm pretty sure most of you know we have rich field types, which are not just columns in a table. What most RM provide is just the field types are just columns, most of them. And we have also other stuff you can read for yourself. Those are things that somehow come. They're not strictly part of the framework, although they're somehow more or less integrated as well. So the user account and permissions, so we already mentioned, Habib already mentioned the security aspect, the security. It's actually fully integrated inside the framework, and therefore you got a model for free, you got the permission models, and you don't have to re-implement their own. If you were using Django, I'm going to keep using Django as an example, you can actually, you have a model for user profiles and defining permissions, but essentially you would have to compose with it. And there, it's not completely integrated in the ORM itself. It's somehow just a layer you have to use yourself for protecting your remote calls from doing things they shouldn't do. Here, it's completely integrated and mostly transparent for the developer, in fact. We also have a multi-company support, but maybe that's a detail, but I mean, for running a business, it's very useful, of course. And this is something you don't find in Django. Basically, what you have in the database reflects what's in your code. So you cannot dynamically say, oh, the user wants an extra field, I'm going to add an extra field. No, you'd have to modify the code to actually do that. In Odoo, we have specific support for that. Of course, I mean, it has its own limitations, but it's doable. We can have our own custom models and fields, and the whole application, application Odoo Studio is built on that. And then we have custom automated actions. Yeah, again, it's essentially a hook that will use to inject in a kind of dependency into an application. So for the comparison, I'm going to go very quick. I already mentioned Django. So it's a Python framework like Odoo. It has somehow, I'd say, a stronger, actually I should say more rigorous MVC architecture. In Odoo, the view, the model, and the controller are somehow mixed into the code, while in Django you do really a class for the model, you do a different class for the view, and you may even have different classes for the controller's part. Okay? One thing that Django is actually far superior to Odoo is it has many more backends. We only can deal with PostgreSQL. If you go for Django, of course, you go to MySQL, Oracle, whatever you name it, they usually have the backend implemented for it. It has many reusable components. So I mentioned the user profiles and stuff like that. The trick is that you cannot extend as such those components. You can only compose them. And it has a much more powerful query set abstraction, which is much more efficient for writing an application. Essentially, you can make some optimizations more easily. So one thing that somehow makes it typically the way you write a Django controller, so something that performs something, is basically you make some query set to determine all the data you're going to need to execute something, to do something. Then you do it, you push it to the database, and then typically you generate some output, which might be rendering a template or something like that. And those query sets, the query set you determine basically will essentially capture all the data you need. The advantage is because those query sets are evaluated lazily, you can combine, get some data, and update it in one query, while the Odoo way is to do it differently. But of course, this works well if you have essentially a holistic view of the whole process you're going to run. If you want to be able to inject any extra bit here and there, which is what we do in Odoo, it doesn't work. So Rails, this is the Ruby on Rails stuff. I'm going to not mention and run to the conclusion. Just come and talk to me if you want to know more. So the key feature that makes this framework somehow necessary for Odoo is the modular part. And the fact that we can extend and not just compose data models, but we can actually extend them. And the same for the views and something like that. And the computed fields is an example of this, this kind of dependency injection we can have with the model. Thank you very much. I think we have time for maybe one question, but hopefully not more. Or maybe two, we say? Okay.
Thank you very much. I'm not so sure if this is very related to the server-side framework, but my question is very much related to just doing simple housekeeping rules, especially when your data and databases are growing. I've noticed that it's a nightmare when it comes to just doing basic things like backing up databases, especially when databases grow to a particular size. Yeah. And of course, it's easier with Odoo.sh. Probably there's a lot of stuff you're doing around there, but even if I was using enterprise, but just outside the Odoo ecosystem, probably on a local or on-premise or a cloud VPS. So the ORM and all the other abstractions that you're adding on, is that the reason why that is probably affecting such kind of things? And I would just want you to maybe comment on that. You find that in the likes of other frameworks, probably Django, you can probably go just a little level lower to deal with those things, maybe work with the databases, work with the backends directly, and just have code pick up. I hope that makes sense. Hope my question was clear.
Yeah. Actually, the framework, the ORM, I'd say the ORM part of the framework, it abstracts quite a lot, but still the mapping between what you write as code and the actual SQL that's being executed is pretty straightforward. It doesn't look like completely alienated from one another. They relate, the mapping is pretty easy. And so for some cases where performance is actually critical for a given operation, a given business operation, let's say, we sometimes somehow skip that abstraction and go straight to the database. Does this relate to what you're saying? So for exceptions, basically what you say that if you're not in a critical situation, this ORM is good enough. It's not the most efficient, but it actually does the job quite well. But sometimes it's not enough, and in that case, typically you have to somehow skip it, escape it, and go straight to the database. Yep.
Hopefully I'm not eating any nerves here, but are there any plans to use a different type of database in the future, non-relational, like, for example, MongoDB? Just wondering if there are any plans for the future.
There's no plan. To my knowledge, there's no plan.
Okay, thank you.
That's okay, I think we're done. So thank you very much, and welcome, Jerry.